Chapter 9. Soil. Lesson Preview. Soil and its composition. Formation of soil. Soil profile. Types of soil. Properties of soil. Soil and crops. Soil erosion. Soil, a natural resource. There are a number of natural resources which are necessary for our survival. Soil is one of the most important natural resources. Do you think life would be possible without soil? The answer is no. Soil is necessary for the growth of a diverse variety of plants and trees. It helps the plants by holding the roots firmly and providing water and nutrients to them so that they can prepare their food. Soil is essential for agriculture. It is the home for many organisms. All living organisms depend directly or indirectly on soil. Non-living things like buildings, roads, and railways are also supported by the soil. Soil is thus an inseparable part of our life. Without soil there would be no food for us or other animals. Soil. Soil is made up of many things. Different organisms live in soil. Soil varies from place to place in color, texture, and its composition. Let us find out the different things present in soil with the help of this activity. You will observe that different things are found in soil from different places. Polythene and plastic articles will generally be found in the soil collected from the roadside soil. Composition of soil. Soil is made up of two main components, tiny mineral particles and humus. Tiny mineral particles come from larger rocks. These minerals include salts of iron, calcium, potassium, phosphorus, magnesium, etc. Many of these minerals are necessary for plant growth. Humus is the other component. It is dark brown in color and contains decaying remains of plants and animals. Soil also contains water, air, and many living organisms. Water and air are necessary for soil organisms to survive, and for dead and decaying matter to be converted into humus. Humus provides organic nutrients to the soil and makes it fertile. It provides food for earthworms and other animals living in soil. It also improves soil texture and prevents minerals from being washed away by water. Besides earthworms, other living organisms like millipedes, centipedes, ants, fungi, and bacteria also live in soil. Many of these soil organisms help to improve soil fertility. Earthworms are called farmers' friends as they loosen the soil by making little burrows, aerate the soil, and allow roots to spread. Bacteria and fungi feed on dead remains of plants and animals and help in the formation of humus. Some bacteria convert atmospheric nitrogen into soluble nitrogen that can be used by plants. This is called nitrogen fixation. Millipedes and centipedes harm the roots of plants. The nature of soil depends upon the following factors: the rocks from which it has been formed, the type of vegetation that grows on it, the climate, formation of soil. The word soil is derived from the Latin word solum meaning earthly material. Soil is the uppermost layer of the earth's surface. The formation of soil is a very slow process. It takes thousands of years to form a layer of soil. You have probably learned that soil is formed by the breaking down of rocks caused by natural forces like the action of wind, water, glaciers, roots of plant, etc. This process is called weathering. The natural forces which cause weathering are called weathering agents. Some of these weathering agents act as described below. Water is a vital weathering agent. Rainwater enters crevices in rocks. In winter, this water freezes and expands. This breaks the rock into smaller pieces. These smaller pieces of rock are moved by flowing wind or water. As they strike each other and against the ground, they break down further. Finally, they convert to very fine particles and mix with humus to form soil. Roots of trees also exert great pressure on rocks when they grow through their cracks, breaking the rocks. Significant variation in day and night temperature, as in North India, also causes weathering. The rocks expand in daytime and contract at night. This continuous expansion and contraction also weakens the rocks and cause them to crack and crumble. In hot and humid regions, high temperatures cause chemical weathering. The minerals present in rocks combine with oxygen in the air. These oxidized rocks crumble to form soil. Soil profile. Soil is made up of distinct layers. Activity. Take a little soil. Put it in a glass tumbler which is filled with water about 3/4. Stir the mixture well with a stick to dissolve the soil. Allow it to stand undisturbed for some time. Observe the contents. What do you see? You will see different layers of soil. The lowest layer consists of stones and pebbles. The second layer consists of sand particles. The third layer is of clay. Above this layer is water. It is not completely clear and consists of salt. The uppermost layer, floating on the water, is called humus. It consists of rotting dead remains of plants and small animals. A vertical section of soil showing its different layers is called soil profile. Each layer differs in feel, texture, color, depth, and chemical composition. Soil is generally arranged in 3 layers called horizons. The 3 main layers of soil are topsoil or A horizon, subsoil or B horizon, parent rock or C horizon. Under the C horizon lies the bedrock, which consists of solid rock. We generally see only the topsoil, and not the layers beneath it. They can be seen while digging of a well or laying of the foundation of a building. You can also see the different layers if you look at the sides of a ditch being dug. Topsoil. Topsoil is the uppermost layer of the soil. It is usually dark in color and rich in humus and minerals. This layer is very fertile and provides nutrients to the growing plants because of the high humus content. It is soft and porous. It can hold water. This layer provides shelter to many living organisms like earthworms, fungi, bacteria, rodents, moles, and beetles. The roots of small plants are completely embedded in the topsoil. Subsoil. The layer just under the topsoil is called B horizon or subsoil or the middle layer. It is lighter in color than the topsoil. It is slightly harder and more compact. It has a higher mineral content than the topsoil. It has lesser amount of humus, but is rich in soluble minerals and iron oxides. Parent rock. This is the layer below the subsoil. It is made up of small lumps of rocks with cracks and crevices. Rainwater collects in the region. It is very difficult to dig beyond this layer. Roots of plants do not penetrate into this layer. The bedrock, which is solid rock, lies below this layer. Rainwater collects over the bedrock to form the groundwater table. Types of soil. Soil is a mixture of sand, salt, clay, and humus. The topsoil consists of 3 types of rock particles, which differ in size, appearance, and feel. These include clay particles, silt particles, and sand particles. The relative amount of particles depends upon the parent rock from which they are formed. The texture of soil depends on the proportions of the particles of different sizes. Based on the proportion of soil particles, soils are classified into sandy soil, clayey soil, loamy soil, sandy soil. Sandy soil contains a large amount of sand particles and very small amounts of silt and clay particles. It is highly porous because the particle size is large. There are adequate spaces between the sand particles which are filled with air. This type of soil is thus a well-aerated soil. The water retention in this type of soil is poor, as it drains off quickly through the spaces. Thus, the sandy soil is dry, well-aerated and light. It is not suitable for the growth of plants. Clayey soil. This soil consists of mainly clay particles and a small amount of humus and silt. Clay particles are fine and there is very little gap between the particles. This soil is heavy and dense. It has high water retention capacity and becomes sticky when wet. There is, however, very little air in the clayey soil. It is however suitable for growth of plants. Loamy soil. This is the perfect soil for growing plants. It is a mixture of sand, clay, and silt. Silt is a deposit in the riverbed. The size of silt particles is in between those of sand and clay. Loamy soil has the right water holding capacity and has enough space for air. It also contains humus. Activity. Take samples of sandy, clayey, and loamy soil and sieve them. Now take a handful of sandy soil. Add water drop by drop and knead the soil. Try to make a ball from the kneaded soil. Repeat this process with the other two types of soil. What did you observe? You will find that only clayey soil could be kneaded and formed into a ball. Try making different shapes, say a ring, a cylinder, etc. Clayey soil is used for making toys, pots, statues, etc. Properties of soil. The three main properties of soil are: percolation rate of water, moisture retention, absorption of water. Percolation rate of water in the soil. The rate at which water passes down the soil is called the percolation rate. The rate of percolation for different types of soil is different. Activity. To find percolation rate of water in the soil, take a small tin can with its bottom cut off. Place the tin about 2 to 3 centimeters deep in the soil. Pour 200 milliliters of water into the tin, taking care not to spill it outside. Note down the time when you start pouring the water. Note down the time when all the water has percolated and no water is left in the tin. Calculate the percolation rate with the help of the following formula. Percolation rate equals amount of water, ml. Percolation time, minute. Suppose it took 25 minutes for 200 milliliters of water to percolate. Percolation rate equals 200 milliliters. 25 minutes equals 8 milliliters per minute. You may carry out the activity with different kinds of soil. The percolation rate of sandy soil is the highest and that of the clayey soil the lowest. Moisture retention. Soil contains water in the form of moisture. Activity. To test if the soil contains moisture, carry out this activity under the supervision of your teacher. Take a boiling tube. Put about 1 tablespoon of soil in it. Heat it on a low flame and observe. What do you see? Small drops of water will be seen on the upper surface of the tube. When the soil sample is heated, water present in it evaporates. It moves up and condenses on the cooler, inner walls of the upper part of the boiling tube. Compare the heated soil with the soil which has not been heated. We can have a rough idea of the moisture content of the soil by the look and feel of it. Absorption of water. All plants need water to grow. The amount of water a particular soil can absorb is called its water absorption capacity. The higher the water absorption by the soils, the greater will be its availability to the plants. Activity. To calculate water absorption capacity of different types of soil, take a plastic funnel. Place a cone of filter paper in the funnel. Place the funnel over a beaker. Weigh 25 grams of dry, powdered soil and put it in the funnel. Measure about 200 milliliters of water in a measuring cylinder. Pour it onto the soil with the help of a dropper. Take care to pour water all over the soil and not just at one place. Keep pouring water till it starts dripping in the beaker. Note down the amount of water collected in the cylinder. The amount of water retained by the soil is the difference between the original amount of water taken in the cylinder and the amount left in the measuring cylinder. Calculate the amount of water absorbed by the soil as weight of soil equals 25 grams. Initial volume of water in the cylinder equals 200 milliliters. Final volume of water in the cylinder equals VmL. Volume of water absorbed by the soil equals 200 V/ml. Weight of water absorbed by the soil equals 200 V/g. 1 milliliter of water equals 1 gram of water. Percentage of water absorbed equals 200 V. 25 times 100. You can repeat this activity with different kinds of soil. You will see from the above activity that the water absorption capacity of the sandy soil is the least and that of the clayey soil the highest. Can you tell the relation between percolation rate and absorption of water by different kinds of soil? Soil and crops. The properties of soil vary from place to place. Different types of soils are found in India. In some places, you will find sandy soil, in other places clayey soil, while in some other places loamy soil. That is why different crops are found in different places. Loamy soil and clayey soil are both suitable for growing wheat and gram. Both types of soil can retain water. Paddy is grown in clayey soil rich in humus, as it has good water retentive capacity. Lentils and pulses require soil with good drainage. Hence, loamy soil is the best for their growth. Cotton requires sandy loam which drains water easily and can hold plenty of air. Sugarcane can be grown in all types of soil. Find out the states of our country where wheat and rice are grown. Soil erosion. The process of removal of top layer of soil by wind or by the flowing water is called soil erosion. It is a natural process. The erosion of soil is severe in places where there is no vegetation like in deserts. Plant roots firmly bind the soil. In the absence of plants, soil becomes loose and can be easily blown away by wind or carried away by flowing water. Human activities are causing heavy loss of soil. The main causes of soil erosion are deforestation, overgrazing in forests, floods and heavy rains, forest fires, poor farming methods leaving the land uncultivated after plowing and tilling. So, we must prevent cutting of trees and deforestation, and at the same time plant more trees and grass. Soil, a natural resource. Soil is our most important natural resource. It is useful to us in various ways. Soil provides us food, clothing, and shelter. Soil supports plant growth and gives us food. Most of our clothing comes from cotton which grows in soil, and wool which is sheared from animals that eat grass and plants, which grow in soil. Timber is used to construct houses and make furniture. Soil provides us minerals. Minerals are dug out from the soil to extract metals such as iron, silver, aluminium, copper, etc., which are used in many industries to produce useful things for us. Minerals like coal, petroleum and natural gas are obtained from soil. Thus, soil provides us fuels and many other useful things. Clay is obtained from soil which is used to make bricks, tiles, porcelain, and pottery. Soil provides us water. Water seeps into the soil and is stored underground as subsoil water. This water is used by us for drinking and many other domestic and industrial purposes.